Hello everyone, Mr. Fawcett here, and welcome back for another geometry lesson. Today the main focus of our discussion is going to be on the segment addition postulate. Before we get there though, I want to review a couple of expressions and how to simplify them. So as always, before you see a problem or before you see the problem done on the video, take some time to work through these four problems under the do now on your own, and then come back once you have some answers. Okay, so for the first problem, we have 7 minus negative 3. If we are subtracting a negative number, that really means we are going to be adding that number. So we get 7 plus 3, which is equal to 10. For number 2, we have negative 1 minus negative 13. So again, if we're subtracting a negative number, that's the same thing as adding that number. So that is going to give us positive 12. Number 3 looks a little different. We have these absolute value signs. So when we have absolute value, the first thing we can do is simplify inside the absolute value. So 3 minus 6 is negative 3. Now, absolute value, all that represents is the distance from that number to 0 on the number line. So real quick refresher. If I have a number line and I mark 0 and I mark negative 3 and also mark positive 3. If I have a point at negative 3, what the absolute value asks us to do is just to find the distance between negative 3 and 0. And the distance is always going to be positive. You could think about, when somebody asks you, well, how far to the store is it, right? It doesn't matter what direction the store is. You're going to say 7 miles or 8 miles. If somebody asks you how far you rode your bike yesterday, again, it doesn't matter if you rode it north, south, east, west. You're going to give them a positive number because that's what a distance is. So with absolute value, your answer is always going to be positive. So the absolute value of negative 3 is 3 because negative 3 is 3 units away from 0 on the number line. You'll notice that that's a pretty poor positive 3 over here. You'll notice that the distance from positive 3 to 0, right, is also 3 units. So essentially, the absolute value of negative 3 is going to be equal to the absolute value of 3. So again, absolute value is just a distance from 0. Okay, let's go on to number 4. How many real numbers are there between 0 and 1? So real numbers include all the types of numbers that you've studied up to this point. If you can think of a number, it's a real one. Okay, and what that means is if we have a number line with 0 and 1, well, can you think of a number between 0 and 1? Maybe you can think of 0.5. Maybe you can think of 0.1 and 0.2 and 0.3, etc. Maybe there's 0.779. Right? We could keep plotting points in this number line forever because you could always just add another decimal to it, right? And it would stay between 0 and 1. So the answer to this question, there are infinite numbers between 0 and 1. Okay, let's jump into some new material for today. All right, let's jump into some new material for today. Clear this. And the first thing we're going to do is we're going to talk about what congruent segments are. We're going to talk about it now, and then we're going to hold on to it for problems later in the lesson because we're going to need to use this property in setting some problems up. So congruent segments are 2 or more segments with equal lengths. You identify congruent segments in images by congruent markings. If segments have the same number of markings, then they are congruent. And also notice that it may be a little hard to see. You may have to make your video full screen. But this is the symbol that says two segments or two things are congruent. So if I had two segments, let's say I had segment AB and let's say I had segment CD. Now I did my best to sort of make those the same length, but we're just going to pretend that they are. If I knew that those were the same length, I could write a congruency statement. I could say segment AB is congruent to segment CD. So the congruency symbol is just an equal sign with a little squiggly on top. That's it. So let's look at an example real quick. It says segment UT and segment RS are congruent segments because they both have two congruent markings, or they're talking about these tick marks right here. Okay, the segments each have two tick marks. That means that they are equal in length. It means that they are congruent. If we come over here and look at these triangles, right, we can match up the sides based on their tick marks, and that's going to show us which sides are equal in length to each other. So pause the video, take some time, write out 3 congruency statements based on which sides are congruent with one another. Okay, I have side AC, which has one, to do that a little bit better. I have side AC with one tick mark. That matches up with side ZX. So segment AC is congruent to segment ZX. I then will move on to segment BC with 2 tick marks, and that's congruent to segment YZ. So segment BC is congruent to segment YZ. Remember, you can switch the order of these letters around, and it is not going to change anything. All right, so you could say segment CB is congruent to segment YZ, and it means the same thing. Remember, for a segment, the order of the letters does not matter. And finally, we have segment BA and segment YX. Those both have 3 tick marks on them, so we know that those are the same length. It is extremely important not to just look at a figure. Let's pretend I had 2 figures here without any tick marks, but we'll label them the same. Okay, you cannot just look at these figures and guess about which sides are the same length, right? If they're not labeled with numbers, if they're not labeled with tick marks, you can't make a guess, right? We have to be precise. We can only use the information we're given. We can't make an inference here and say, well, it looks like segment AB is the same as segment XY, so I'm just going to put tick marks there. We can't do it. We have to be told that they're the same. Otherwise, we can't make any assumptions whatsoever. Okay, so hopefully that gives you a little introduction to what congruence means. Again, we're going to put this on hold. Just pay attention to this idea right here of the tick mark idea. So if you see segments with the same number of tick marks, you can assume that they have the same length. That's going to be important later. All right, we're on to the next page. So the first thing you're going to do is it says find the distance between the 2 points on the number line below, and be prepared to explain your reasoning. Note that there are multiple ways of doing this. So again, this may seem rather easy. That's okay. Go ahead and do this. Write out your explanations, and then we'll have a discussion on it. Okay, so like I said before, the distance is always going to be positive. So if we just find the distance between these 2 points, there are many ways of doing it, but the distance there is going to be 4. And you may have had a different reason than your neighbor. Some of you may have said, well, I just counted the spaces with my pencil or my finger. 1, 2, 3, 4. Right? I think that's probably what our head did in this scenario, because that may have been the easiest way to do it for this example. Others may have tried something else. maybe you tried adding, right? So maybe you did -3 plus 1, and you got -2. But then you were like, okay, the distance is clearly not -2, right? Distance can't be negative. So maybe you tried another operation. Maybe you did -3 minus 1, and you got -4. Well, okay, the distance, we know that it's 4 intuitively, right? And we can just count it with our fingers. But this is giving us a negative answer. So this can't be the correct way to do it if it gives us a negative answer. So then maybe you try something else. Maybe you switch the order of the numbers. Maybe you do 1 minus -3. Oh, okay, 1 minus -3 is the same thing as 1 plus 3, so that does give us 4. We're onto something here. To find the distance between 2 points on a number line, you can find the difference. So to find the difference, find the distance, there are 2 D words here. To find the distance, use the difference between the numbers. However, we had two differences here. In one, we started with -3. Down here, we started with 1. One of these was negative. One of these was positive. Well, let's think back to our do now. Is there something that would always make an expression positive? So it doesn't matter what order I subtract the numbers in. Okay, and maybe you want to pause the video, go back up and look at your do now. Is there some sort of operation that I can use to always make something positive? Well, if you went back up and checked, we would see that that's the absolute value symbol. So if we do the absolute value, right, it wouldn't matter, right? This is going to give us the absolute value of -4, which is equal to 4. And if we did it the other way, we would get 1 minus -3, or sorry, the absolute value of 1 minus -3, which is the absolute value of 4, which is equal to 4. So if we just put absolute value symbols around our expression, it wouldn't matter which numbers we subtract. And this is nice because you don't have to think about which number to subtract from the other one. You can just subtract either number from either one and just take the absolute value. So let's start answering these questions. To find the total distance between 2 points on the number line, we need to find the difference between the 2 points. We know that the operation needed is difference equals subtraction, or implies subtraction. So the distance between 2 points on a number line is found by blank or blank. And we're going to assume that A and B are the given points. So we can either do the absolute value of A minus B, or we can do the absolute value of B minus A, right? As long as we have those absolute value signs, it doesn't matter which number we start with. Now you may say, Mr. Fawcett, why do I need to use this absolute value formula? You know, I haven't worked with absolute values a whole lot up until this point. I don't really want to start doing it now, right? Can I just count the blocks in between? Well, you can count the blocks, but depending on how far apart the numbers are, you may be counting for a while, right? And they may draw the number line so that you're not even able to count the blocks. If I give you a number line like this, and I give you 2 points, we'll say they're at -87 and 135, right? And I say find the distance between those points. Well, what are you going to count, right? You can't just put your finger on the number line and count to the right or count to the left. It's not going to work. So we have to have a tried and true method that works regardless of what the number line looks like, right? The counting the blocks method works if the points are close together and they give you each tick mark in between, right? But over here, there's no tick marks in between, right? There's just the 2 tick marks where your points are at. Let me erase this. So just become familiar with this method. It's not hard once you understand the concept of absolute value. Okay, let's do, I think we'll finish this page and then we will call it a video for today. So for number 1, it says find the distance between A and C, and for number 2, it says find the distance between A and B. So pause the video, take a shot at finding that. I would encourage you to use the absolute value formula rather than just try to count, and then come back and see if you're right. Okay, distance between A and C. Well, I'm going to take the absolute value of 6 minus -2. That's going to give me the absolute value of 8, which is equal to 8. We could have done this the other way, right? We could have done the absolute value of -2 minus 6. That will give me absolute value of -8, which is also equal to 8. So regardless of which way you did it, you should end up with 8. For this one, you could have counted the blocks, but for number 2, you couldn't do that. So for number 2, it'll be the absolute value of 160 minus 20, gives us the absolute value of 140, which is equal to 140. Or we could have switched the numbers and we could have done the absolute value of 20 minus 160, gives me the absolute value of negative 140, which is equal to 140. So either way, the distance is 130. Okay. Now let's look at the segment addition postulate. This is where we're going to end the video, and then in the next video we'll actually look at some practice problems using the segment addition postulate. So the segment addition postulate states, if 3 points A, B, and C are collinear, think about what collinear means. It means they all lie on the same line, and B is between B and C. So that just means that A and C are our endpoints, and B is somewhere in between those 2 points, but on the same segment. Well, think about, let's think about taking a pencil in your hand, right? Or take a pen. In my hand, currently, I'm holding a green Papermate Flair pen, and all I did was take the cap off. So if I take the cap off, the segment addition postulate says, if I put 2 pieces of a segment back together, then it's going to equal the whole segment. So in my hand, I have a pen. I break it apart. I take the cap off. The segment addition postulate says if I add the two individual pieces, they will give me the length of the whole piece. So we can write an expression for this. It's just going to say AB plus BC is equal to the entire segment AC. So when I say AB, because we're talking about the length of AB, we don't use the bar on top of the 2 letters. So if you're just naming a segment, if you're just saying this is segment AB, then you need to use the bar on top. If I wanted to name this segment, I would have the bar and then AC. Right? But if I'm just talking about the length of a segment, then I remove the bar and I just put the 2 letters. Okay? Let me show you. Let me give you one more example before we quit the video here. So I have this segment AB. Okay? Let's say that I break AB off. So I'm gonna get rid of AB for the moment. Okay, and I'm just left with BC. Well, AB didn't disappear. Okay, I'm putting it over here. Okay, so if I remove AB from my entire line segment, well, let's put some numbers here. Let's say AB is 5, BC is 6. Well, AB, so 5 plus BC, which is 6, would give me 11, right? It doesn't matter whether these pieces are together or whether they're separate, right, they're still going to equal 11 when I combine them. So the way I have it right now, the sum of these segments is 11. Or if I brought them back together, right, if I brought them back together, the total length of the segment is still going to be 11. That's all the segment addition postulate says. It says you can add pieces of the segment to equal the entire segment. Okay, we're going to fill in these blanks, and then we'll call it quits for today, or for this video. So if AB is 5 and BC is 4, let me erase this so you're not confused again. So AB is 5, BC is 4. So AB plus BC is equal to 5 plus 4, and AC would be equal to, oops, let's do a better 5. AC would be equal to 9, right? And again, it doesn't matter that it looks like AB is longer than BC. This doesn't have to be drawn to scale. We can't assume just because a segment looks smaller than another one that it actually is, unless the image says that it's drawn to scale. Another way we can understand the segment addition postulate is if we know that the whole value of the segment, or the whole length, is 12, and we know that a piece is 7. So let me come over to my segment and rewrite this based on what I know. So I know the whole segment is 12 AC, and I know that BC is equal to 7. So we need to find AB. Well, obviously this would just be a subtraction problem. If I take away 7 from 12, all that's left is going to be 4, or 4, yeah, 5. Right, so AC minus BC would be equal to 12 minus 7, and AB would be equal to 5. Okay, you may need to rewind that and listen to that again if you are still a little confused as to what this postulate is saying, but we are going to come back next video and use this idea to solve some more complicated problems. We'll include some variables as well as some numbers. Until then, this has been Mr. Fawcett. As always, enjoy the rest of your day.